today's video, we are going to be looking at 6-mark limiting reactant calculations. Please make sure you are secure in your reacting mass calculations before having a go at this video. Here is my first worked example. I'm going to read through the question and I'm going to highlight the important information. 112 grams of iron reacts with 96 grams of sulfur to produce iron sulfide. Immediately, I can connect that to my equation. The iron reacts with the sulfur to make iron sulfide. Calculate the maximum mass of iron sulfide produced in grams. Maximum mass produced in grams. You should determine the limiting reactant. As soon as you see that, you know this is a 6-mark question. It gives you the relative atomic masses here for iron and for sulfur. So, we're going to get started in a very similar way as we do with our reacting masses. We're going to identify the substances involved in our reaction. In this case, I've got iron, I've got sulfur, and I'm calculating the mass of iron sulfide. So I will need to have 3 columns: iron, sulfur, and iron sulfide. I'm going to start now by recording the mass. Now the mass of the iron has been given to me here. I've got 112 grams of iron. I also have been given the mass of the sulfur. I've got 96 grams of sulfur. And I'm trying to calculate this final mass. I'm going to then look at the relative formula mass. For iron, this is 56, and for sulfur, this is 32. I've been given this in the question. I'm now going to calculate moles, and I'm going to show my working at each point here. 112 grams divided by 56 will give me 2 moles of iron. 96 grams of sulfur divided by 32 as my relative formula mass gives me 3 moles of sulfur. And I'm just going to add my ratio, my molar ratio underneath. I've got a 1 to 1 to 1 molar ratio. This is the part where I now need to identify the limiting reactant. And what that means is I need to identify whether it's the iron or sulfur that will limit how much iron sulfide is made. So I need to write 3 sentences here. And I'm going to look first at my iron. So if I have 2 moles of iron, the maximum moles of iron sulfide I can make with my 1 to 1 ratio is 2 moles. So my first sentence will say 2 moles of iron will make 2 moles of iron sulfide. And I'm now going to do the exact same thing with my sulfur. I'm going to apply my ratio. Now 3 moles of sulfur will make, with my 1 to 1 ratio between sulfur and iron sulfide, 3 moles of iron sulfide. Now the reactant that makes me the least moles of iron sulfide here is my iron. So therefore my iron is the limiting reactant because it's limiting how much iron sulfide I can make. So my final sentence needs to say, therefore, iron is the limiting reactant. And when I now carry on through my reacting masses method, I'm going to only consider the iron. So I'm now carrying on with the same method as I did in my reacting masses. To go from 1 to 1, I multiply by 1. So to go from 2 to the final answer, I multiply by 1, 2 moles. I'm going to look at my relative formula mass, which is going to be 56 plus 32, for my iron and sulfur, which will give me 88 as my relative formula mass, and my final mass will then be my moles multiplied by the relative formula mass, which will give me 176 grams of iron sulfide. In terms of my mark scheme, I get 1 mark for calculating the correct moles of iron. My second mark comes from calculating the correct moles of sulfur. My third mark comes from comparing these two reactants. Both of these sentences is your third mark. The fourth mark comes from identifying the limiting reactant. The fifth mark comes from your final calculation of the mass, and the sixth mark comes from your final mass. This is my final worked example for limiting reactants. We're going to follow the exact same method as previously. I'm going to read the question and highlight the information. In this case, 108 grams of aluminium reacts with 1.21 kilograms of copper chloride to produce copper. I am worried now about the copper. Calculate the maximum mass of copper produced in grams. You should determine the limiting reactant, and we are given the information. So we're going to start the same way as always. I am going to start my columns with the substances that are involved. So I have aluminium 2Al, copper chloride 3CuCl2, and copper, which is 3Cu. I am then going to get my mass. The mass of aluminium is 108 grams, and the mass of copper chloride is 1.21 kilograms. But my final answer needs to be in grams, so I need to convert here, and I do that by multiplying by 1,000 to give me 1,210 grams of copper chloride. I am then going to look at my relative formula mass, which it has given me in the question. Al has a relative atomic mass of 27, and CuCl2 has a relative formula mass of 134.5. I'm now going to calculate my moles. Moles is equal to mass, 108, divided by relative formula mass, 27, which is going to be equal to 4 moles. For this example, I am going to have 1,210 divided by 134.5, which gives me a final answer of 8.99628 moles. And my ratio, based on these numbers at the front, my molar ratio is 2 to 3 to 3. Okay? Now I need to write my sentences. I am going to start by looking at aluminium. 4 moles of aluminium will make, and I'm going to apply my 2 to 3 ratio here. So I need to multiply by 1.5. So this will make 6 moles of my copper. And I'm going to now do the same thing here with my copper chloride. I've got 8.99628 moles of copper chloride. I have a 3 to 3 relationship, which can be simplified to a 1 to 1. So if I have this many moles of copper chloride, I will make the same amount, because we've got a 1 to 1 relationship, so 8.99628 moles of copper. Again, the thing that makes the least moles is our limiting reactant. So in this case, aluminium is the limiting reactant. So my final sentence needs to be aluminium is the limiting reactant. And I'm now going to apply my ratio through this reaction. I had a 2 to 3 relationship, so I would multiply by 1.5. So I'm going to do the same with my moles. I will multiply by 1.5 to give me 6 moles of copper. My relative formula mass of copper given to me in the question is 63.5, and my final mass will then be 6 multiplied by 63.5, which is going to give me 381 grams of my copper. That is my final answer. In terms of our marks, you will get 1 mark for the correct mole calculation, 1 mark for the correct mole calculation, 1 mark for these 2 sentences, and 1 mark for identifying the limiting reactant. You will get your 5th mark for your final mass calculation and your final mark for your final answer. Have a go at this question. Pause the video so you have time to answer. Please see the mark scheme for this question. I have put a tick at every place you will get a mark. If you got 2 grams of hydrogen, you have full marks. Please have a go at this exam question. Pause the video and give yourself time to answer the question. The mark scheme is on the board. Again, there is a tick for every position in which you will earn a mark in your exam. Please have a go at answering this exam question. Pause the video to make sure you have time to answer. The correct answer is on the board now. Again, there is a tick next to every moment where you will find a mark in your exam. Have a go at this exam question. Pause the video to give yourself time to answer. The mark scheme is on the screen now. There is a red tick in every position where you will get a mark in your exam. Have a go at this exam question. Pause the video so you have time to answer. The mark scheme is available now. There is a tick in every position where you can find a mark in your exam. Please have a go at this exam question. Pause the video so you have time to answer. Please find the mark scheme for the final question. There is a tick in every position where you can find a mark in your exam. If you have any questions, come and find me and let me know how your revision is going. Thank you.